much more quickly. So we'll do the same thing. First of all, we're just going to anti-differentiate the 2 to get 2x plus c. Okay, and we are given here at x is 0, t is 40, and at x is 100, x equals 100, t is 400. Okay, so I only have one variable to solve for, and again, I can't really plug it in because I don't have any information about the first derivative, but I have something about the original t function. So I'm going to anti-differentiate again. And I'm going to end up with x squared plus cx plus another constant I'll call k. And again, we have two variables to solve for. This time it's not a linear function, it's a quadratic function. However, we can still solve this because we have 2 points, which gives us 2 relationships, so it allows us to solve for 2 variables. So at x is 0, we know that k is equal to the 40 degrees on one end. K equals 40. Okay? And then plugging that in, when t is equal to 100, we know that the x is equal to 100, the temperature is 400, and you know it's going to follow x squared, or 100 squared, plus c times 100 plus 40. Okay, and then I can solve this. I can solve this for c. So I end up with what's that? 10,000 plus 40. So it's going to be negative 9. Oh, I better do that on a calculator here so I don't make a mistake. 400 minus 100 squared minus 40 is negative 9,640, and that's equal to 100c. And I can then calculate c. So c equals negative 96.4. Okay, so then my equation looks like this. Temperature as function of the distance x is going to be x squared minus 96.4x plus 40. So there is my temperature function. I had to anti-differentiate and solve for c as I did it in steps. So again, in general, anti-differentiating is the opposite of the derivative, okay, of differentiating. So that's a general idea we want to just make sure we understand. We also looked at before the area of the curve has something to do with this antiderivative. And we also want to then relate finding the area of the curve then is the opposite of finding slope. Okay, so they're essentially opposite operations. So the derivative and integral are opposite operations. So what do we say about finding area of the curve and the antiderivative? Well, we know that they are related as opposites. They're related, and we know that the area under the curve is equal to the displacement or the change in the antiderivative function, or big F. Okay,